we now look at the proof obligation that is related to invariance number 4, which says the elements that we are looking for, which is V, is a member of the relational image of relation or function f applying to the range of P up to Q, which means the elements we are trying to find is always in the interval of P and Q, in the indices interval of P and Q. So this cannot currently be proved as maintained by the events of increments. So a very easy way to fix this is to add a theorem, and which has a very similar form as the original invariance. So let's just copy and paste this guy here, and let's go to the increments events, and let's add a guard, and we have to declare that as a theorem. And now let's consider what we should put over here instead of P and Q, because in the case of increments we have changed the value of P from P into R plus 1. So here, instead of P, we have to put P prime, which is R plus 1. And this will help the theorem prover to say now we have correctly maintained the invariance. However, we have to prove instead that this derived theorem is true. In the next video, we'll show you how this theorem can be proved.